Let's now discuss some security properties of FIDO. And to make it easier to understand, let's use a password to contrast the way that password does things and the way that FIDO does it. And to illustrate that, let's use two different scenarios. One is the theft of the credential, the password or the FIDO credential, and the other scenario is phishing. Um, so let's begin with the theft of passwords. And for that, let's first begin with the fact that typically passwords are centralized in one place, right? So typically a database is going to have all the passwords for all users in this system. Good practices tells you that the password, when it's stored, they need to be hashed and salted and all that good stuff for securing this data. However, putting that aside, anyway, the attacker, if it finds a vulnerability how to access the server, they could extract this data, and who knows, maybe they find a way how to actually use it. So it's better they not having access, right? So that is a situation that has to do with passwords and the storage, the centralized storage of the password. Now the transmission, typically the common practice is if there is an authentication, the user types the password and then it is sent over the internet. It's typically sending a secret, in this case a password over the internet is not good, right? So if you can avoid it, avoid it. Don't do it, because the attacker might find a way how to intercept. It could be intercepted in many different places when it's transmitted. So yeah, it could be protected with HTTPS and maybe the application itself performs some cryptographic operation to protect it. But anyway, there might be some hole in there that the attacker can use. So it's possible for them to intercept this password, and maybe even possible that they have access to this in plain text and they can use it. And it could be bad if the operation that is going to be performed or this password actually gives access to some possible execution of a sensitive transaction. So the password comes with these problems about how they are stored and the practice of sending the password over the internet. Now let's compare with FIDO. Okay, FIDO. Let's first talk about the FIDO server. The FIDO server typically is going to have the public key and any public information about the credential, right? So that is what's stored in the FIDO server. So if the attacker has access to this, there is really not much that they can do. I mean, obviously better if they don't have this data, but if it happens, there is not much that they can do. I'm going to come back to the server because there is something else to discuss on the server. But then if we go back to the client, the client is going to keep the private key. Why? Because FIDO requires the private key to be available on the client. It's kept inside the authenticator, right? So that means that if we contrast passwords and FIDO, with password, it's a more centralized approach where everything is found together. And with FIDO is more like a distributed approach where if an attacker wants really to have access to these private keys, they will need to go to as many clients as they can. and find a way to extract the private key from the authenticator. That is not going to be easy. So if you can see the approach from a security standpoint about having the private keys throughout all the clients helps you in improving the security. Going back to the server from a storage perspective, so there is another server that plays a role here that might need to keep the private key. But this, I just want to make the clarification. This is implementation specific. Is not something that is specified in FIDO about how to do it. But it has to do with the idea of the private keys being synchronized across multiple devices. So if the FIDO credential or the private key is created once and then it needs to be synchronized to other devices, a common implementation technique would be to send that private key to a server, and then from that server to distribute to all other clients belonging to the same user this private key. And the reason to keep it here is because maybe later the user now shows that it's using another device. So the server is ready to synchronize this material into the new device, the new authenticator. So that is why this could be a potential way how to implement the feature of synchronizing FIDO credentials. So still talking about the storage aspect, this is called either single device key or multi-device key. A single device key from a security standpoint is better because no matter what, the client has to have the private key. And if you do it in a way where you create a key and that key never leaves the authenticator, which is again, the private key is hardware protected, then how can the attacker can get a hold of these private keys is very hard. But if you do it multi-device, then there's going to be some synchronization here, right? Which means that the private key needs to be transmitted over the internet. So that could be a potential problem for from a security standpoint. In the case of the single device, whenever the private key is used, only public information is transmitted. So whenever the key is created and then used, there is transmission. There is only public information. But however, when the FIDO credential is created to be synchronized, then this is where the private key needs to be sent in order to be able to synchronize later to all the devices where it needs to go. So from that perspective, it could be a problem from a security standpoint. So the summary on this is that single device keys from a security standpoint are better because the surface for the attack is less. With the multi-device key, you're expanding the surface and open the door to additional security possibility, right? Obviously, you gain some usability, very nice idea of just synchronizing, and from a usability perspective, that's great, but it comes with some security considerations. Now, let's move to the phishing scenario. On the scenario that I'm going to discuss here is about the user is using some application, some client, and they believe that they are interacting with a legitimate website, where they have a relationship with that website. However, in this scenario, um, the attacker is tricking the user into believing that they are interacting with a legitimate website, but it's in reality an attacker. How? Because maybe the website looks exactly the same. There is really not a visual difference in one or the other. Um, so the user might be tricked into providing the password, which means that now this password is leaked to an attacker and they can do whatever they intend to do with the password. From a system perspective, it's really not possible to do anything because the password is not bound to anything. So the password is just typed by the user, and then this password could be applicable to potentially, in theory, to any website, right? So it is just sent and then used on the server. So the only possibility is to educate the user to pay attention to the little details. In this case, paying attention to the domain name. If it is not a domain name that they recognize, don't do this interaction. So password is prone to phishing. Um, Now let's talk about FIDO from the phishing scenario. Um, as I mentioned before, the client is going to have the private key. Now, when this private key is created, it's created in a way that is bound to a domain name. What does this mean? Well, it means that this private key can only be used in the context of this domain name. And who is enforcing this is the client, the browser, and then enforced by the authenticator to say, I don't find any key for this domain, or this is only the only key that I can use. So bottom line is the attacker cannot use their own domain to have access to the private key that belongs to the legitimate website. So uh, it means that the FIDO credential, with the help of the client, the FIDO client, and the authenticator, is resistant to phishing because they will refuse to actually perform the FIDO operation because it's not going to even find the private key. The only way how in this scenario the attacker could overcome this is if they gain control over the domain name, right? Because if they actually control the domain name, then yeah, they will have that access to all of this, but then it's really not a phishing attack because the user is not being tricked. It is the real legitimate website. So um, bottom line is password is prone to phishing attacks. FIDO protects the user against those type of attacks.